going to take a look at these three problems that are typical problems that will show up on the first cluster competition of our Mathletics competitions. We have find the sum of a sequence. So the long-winded explanation, which I am going to do, is this. If I were to take the sequence as written and write it a second time, but only this time in descending order, so 190, so I put 22 here. I notice that my counting number here is 14. So what is 14 less than 190? It is 176. So then I'd have 176 here with the 36 over it. And so I'd just be repeating this pattern just in descending order. And I notice that if I were to find the sum of each of my vertically stacked problems, I would get an answer of 12 every time. So that means that I have a bunch of groups of numbers whose sum is 212. And so I'm going to put S here for sum. The trick here is I need to figure out how many groups I have. So what I'm going to do is, to find that number of groups, I first need to find the range. And the range here is going to be 190 minus 22, which gives me a total of 168. Now, that does not mean I have 168 groups. It means that I have 168 spaces or numbers that I need to travel to get to 190. But that's if I was counting by 1. I'm not counting by 1. I'm counting by 14. So my counting number is 14. And to figure out how many times I need to move away from 22 to get to 190, I have to divide 168 by my counting number, which is 14. And I get 12. But wait a second. That is how many spaces away from 22 I must travel to get to 190. If that's giving me the spaces, these little hump type things, that means that I'm not actually counting 22 in that group of 12. So I will always have to add 1 to account for the number at which I start. 12 plus 1 is 13, so I have 13 groups. And each group is 112. Well, that's pretty easy. That means that the sum of both of these sequences combined is 212 times 13. But wait, I don't want to know the sum of 2 of these sequences. I only want to know the sum of 1 of them, which means I'm going to have to divide this by 2. Well, it's a lot quicker to divide 212 by 2 than it is to multiply these things together and then divide by 2. So if I divide by 2, I get 106, which means my answer is going to be 106 times 13. And let's go ahead and multiply this together. It doesn't really take too long to multiply it together. So that means that the sum of this sequence is 1378. Now, in the past, most mathletes tend to prefer to just learn the algorithm than know the reason behind why it works. And so here's the algorithm for those of you who are good at memorizing. You're going to take the sum, and you're going to multiply the sum by the range divided by the counting number plus 1. And then you're going to divide that whole thing by 2. And so that is the algorithm that you can use to get it a little bit quicker so you don't have to logic your way through it. Anytime now. All right, the second question. The mean of 5 numbers is 13. The largest number is removed. The mean of the remaining numbers is 12. what is the number that is removed? Well, if I have a mean of 13 with 5 numbers, that means 13 times 5 is going to give me the total number of, or total value of all of the numbers combined. So 5 times 13 is going to be 65. Well, one number is removed, and now I have a mean of 12. So that means I have 4 numbers with an average of 12. So when I multiply these together, I get 48. Well, with all 5 numbers, I have 65. With one of them removed, I have 48. Well, that means the one number that was removed is the difference between these two products. So 65 minus 48, I obviously can't take 8 away from 5, so I have to borrow, is 17. By the way, there is no shame in writing out your work. You don't have to do it in your head. It's better to write it out, get it right, than it is to do it in your head and get it wrong. All right, computing scientific notation. Now, I have essentially 2 numbers. So this is one number in scientific notation divided by a second number. And it is written in scientific notation because these numbers are bloody huge. And there are a couple ways I could think about going about it, but the easiest way is to think about it as 2 separate problems that I'm then going to multiply together. So if we have 3.9 over 5, I'm going to multiply that by 10 to the 7th over 10 to the 11th. Well, let's deal with this piece first. So if I have 3.9 divided by 5, well, I know 5 isn't going to go into this evenly, so I'm going to just put the 0. Now I know 5 will go into it. 5 does not go into 3, but 5 does go into 39. It goes into 39 7 times with a remainder of 4. So 5 goes into 48 times. So this piece right here is going to be equal to 0.78. Now, in the 8th grade math today, you learned, and I know many of you are not in 8th grade math, but we learned that the rule for exponents is when you're multiplying, or sorry, when you're dividing a number that has the same base, you're going to, and has exponents, you're going to subtract the 2 exponents and the base remains the same. So in this case, my base is 10, which means if I'm following this logic, if I have 10 over 10 to the 7th divided by 10 to the 11th, this all is going to be equal to 10 to the 7th minus 11th. Well, what is 7 minus 11? I feel like a Slurpee. 7 minus 11 is going to be negative 4. So we have 7.8 times 10 to the negative 4th. Well, the problem with this answer is that we have no number other than 0, but we don't have a number larger than 0 to the left of the decimal place. In other words, we need to move this over 1 space. And since I'm trying to make this larger, that means I'm actually dividing this by 10, so I get a number 1 space to the left of the decimal space. Which means this number here, this exponent of 10, since I'm dividing this by 10, is going to get 1 bigger. Or actually 1 smaller, because negative 5 is less than negative 4. So that means we end up with, I'm going to write on this line, even though it's the wrong answer blank, 7.8 times 10 to the negative 5th, because of having to move this decimal place 1 over. Coefficients. All right, so we have x to the 3rd minus 2x squared plus 3x plus 5. And we are multiplying it by 2x to the 3rd plus 3x squared plus 5x plus 1. All right. And we want the coefficient of x to the 3rd. Well, how can I get x to the 3rd? Well, if I multiply x to the 3rd times x to the 3rd, I get x to the 6th. That's not what I want. But if I multiply x to the 3rd times 1, I will get an x to the 3rd, right? So what is x to the 3rd times 1? Well, it's just plain old x to the 3rd, or 1x to the 3rd. What am I going to multiply this piece to get x to the third? Well, if I have two x's, I need an additional x. So I'm going to multiply it by this term right here, 5x. Well, negative 2x squared times positive 5x is going to be negative 10x squared. You probably see a visual connection here. Essentially just having a bunch of rainbows, right? Or one big rainbow as your sight may see. So 3 times 3 is 9, which is a positive because I have two positive 3's. X times x squared is x to the third. And then finally, right here, 2 times 2 is 10, and we have x to the third. So looking at this, I know that 10x to the third minus 10x to the third, sorry, I should have written to the third, well, those are going to cancel out. So x to the third plus 9x to the third is 10x to the third. And looking back at the question, they're asking for the coefficient. The coefficient is just the plain number, 10. So I will write a 10 on the answer blank. If I write 10x to the third, I'm going to get this wrong, because again, they only want the coefficient. Finally, the last problem. This one actually requires a little more computation, and in the interest of getting this video under the 15-minute barrier, I'm going to use a calculator. The lunch bill for 4 individuals came to $35.27. If they also left a 15% tip and divided the total amount evenly, how much did each friend pay? Round your answer to the nearest cent. So the first thing you're going to do is figure out the tip. The quick way of figuring out tips is this. You take the number, and then if you move the decimal place over 1, that's 10%. So I know 10% is $3.50, and it says round to the nearest, where does it say round to the nearest cent? I'm going to keep a little extra decimal places here just in case. And so if this is 10%, 5% is half of this. Well, what is half of this? So let's divide it by 2. So 5% is going to be equal to 1, carry the 1, 7, carry the 1 again, 6, carry the 1 again, and that is 8, and then 5. So that means my tip is going to be 12, carry the 1, 2, carry the 1, 12, carry the 1. Oh my goodness gracious, did I somehow mess this up? I did. I'm sorry. I should have stacked it better. So I have the 5. Okay, so I have 5 here. So I have to borrow to get that. So then, so 16, that's 8. Borrow is 4. That's now 12. So that's 6. So then I have to borrow here. What? Oh, I'm adding. Oh, why am I subtracting? I'm subtracting because subtracting is really, really fun. I don't know what's more fun than subtracting. Maybe adding. All right, so let's add this time. 5, 15, carry the 1. So that is 10, carry the 1. 13, carry the 1. So that is $3, $4, $5. So we have $5.31 as my tip. Yeah. Okay. So then we have $35.37, and we're adding my $5.31. So we have a total bill of $40.68. That must be divided by 4. I can double check here. So we can go 35.37 times 1.15 Yep, we're good. All right, and so now we need to divide it by 4. And obviously just divide it by 4. And so we get $10.17. In Mathletics, don't label your numbers, because if you get the label right, no big deal. You get the label wrong, even if your number's right, they're not going to count it. So at that point, that's all you do.